Our coverage of the launch of 41 Bravo, Space Shuttle Challenger, set to blast off in about 13 minutes or so. I'm Lou Waters, with me Mike Lowndes. The weather is fine. There were a few little problems. What were they all about?
Well, one problem was one of the auxiliary power units has a heater circuit on it to keep the thing at the right temperature, and it wasn't coming up to the right operating temperature. So they had one of the mission specialists on the flight deck reconfigure to a redundant set of heaters, and evidently that's working fine.
We had a lot of computer problems on the last flight of Columbia in December. As it turned out, I guess small slivers of metal got involved with the inner workings, and that's all been corrected for this flight.
Yeah, apparently there was some kind of metal sliver in zero gravity, managed to float around and short out some contacts inside two of the computers. We've very carefully screened the computers we have in Challenger for this flight to make sure we don't have a similar problem.
Where would those have come from? Is it a matter of making sure everything is up to snuff before the flight, within the orbiter, or what? Where would those?
It would have been in the production process for those units because they're sealed, so it would have been something associated with their fabrication.
Okay, now about the abort.
This is Shuttle Launch Control, T-minus 9 minutes and holding. Approximately 7 minutes into this planned 10-minute built-in hold. NASA Test Director Stan Gross has completed his poll of the various test conductors, including those responsible for the vehicle, the spacecraft, the range, the tracking stations, and mission control, and verified we will be ready to come out of this hold at T-minus 9 minutes and proceed with the launch of STS-41-B at 8 o'clock this morning. Commander Brand and pilot Gibson reported they were go to resume the count and go for launch, and the final okay given by Launch Director Bob Seek. Prior to that poll, Launch Director Bob Seek did wish the crew a very safe and successful trip and commented that he hoped to see him back at the Cape a week from Saturday. Commander Vance Brand adding that they too hope to be back and appreciated the very hard work that the launch team and all of the people associated with the shuttle program have done to get this mission ready for launch today. Several major milestones remain between now and launch as we come out of this hold. The ground launch sequencer will take over control of the countdown. T-minus 7 minutes 30 seconds where we will track the orbiter access arm, and at T-minus 5 minutes, pilot Gibson will throw the cockpit switches that will start the auxiliary power units. Now we will terminate liquid oxygen fill and start drain back at T-minus 4 minutes 55 seconds. This conditions engines for launch and provides the proper amount of oxygen propellant inside the tank for flight. We'll do the final purge of the shuttle main engines at T-minus 4 minutes and start a gimbal check of the orbiter aero surfaces at T-minus 3 minutes 55 seconds. The orbiter will go to internal power at T-minus 3 minutes and 30 seconds. We'll follow that with an engine gimbal check at T-minus 3 minutes and 25 seconds. Box tank pressurization and removal of the GOX vent hood will start at 2 minutes 55 seconds, and we will pressurize the liquid hydrogen tank at T-minus 1 minute and 57 seconds. And our final milestone is the transfer of the control to the onboard computers at the T-minus 31 second mark. Engine start occurs at 6.6 seconds. We'll be at 90% thrust at T-minus 3 seconds with an SRB ignition at T0 or 8 a.m. Eastern Standard Time.
Okay, hope you got all that. What I got out of it was things are going smoothly.
6 seconds away now from resuming the countdown. Looking for an on-time launch of 41B and its 5-man crew at 8 a.m. Eastern Standard Time.
Mark Hess in Mission Control, he mentioned 90% of thrust. Does that indicate normal
Countdown
thrust?
Will start at T-minus 9 minutes in
I
4,
missed what he
3,
said, Lou, about
2,
90%.
1.
We're
We
just
are at
coming out of the
T-minus
hold.
9 minutes and counting.
There
Ground
goes the
launch
clock.
sequencer has been initiated.
Okay, there's no more planned holds after this point. If we have a problem now,
Chase
we'd
aircraft
stop the
now
clock
beginning
and,
their
try to
takeoff
solve
from
it.
the shuttle landing facility, and we have turned on SRB development flight instrumentation recorders. T-minus 8 minutes, 38 seconds, and counting.
The clock is
Mission
moving.
Control has turned on the auxiliary data system and the aerodynamic identification package. That recorder will collect data from those packages during the mission for playback and evaluation after the mission.
Okay, just before Mark Hess got on the line there, I was asking you about abort procedures for this mission. I understand the transatlantic Dakar first stop socked in today. What does that mean?
We have an abort site in Dakar, which is on the African coast. What we do during a launch emergency where we would lose an engine depends on when it happens. If we lost an engine in the first 4 minutes of flight, we could come back and land at Kennedy. After 4 minutes, you're too far east and going too fast to be able to come back. So our next abort opportunity would be going across the Atlantic and landing at Dakar in Africa about 23 minutes after liftoff. The weather being bad at Dakar means we couldn't use that as an abort site, but we do have the ability to throttle up to a maximum of 109% of rated thrust on our engines, and therefore to fly onto orbit if we lost an engine after our last return to Kennedy opportunity.
Is that significant then, what Mark has said about 90% of thrust?
I didn't hear him say 90. He may have said 109. 90% is way too low a thrust. We normally lift off at 100%, and when we clear the tower, we go to 104%, with 109% as kind of a hip pocket emergency throttle setting if we needed it.
And when Mark Hess was talking, you were mentioning that this is the last hold. We've just gone past the last hold, and if the clock should stop now, there'll be a 24-hour delay.
T-minus 6 minutes, 30 seconds, and counting.
You see the white room being retracted there.
This is when the astronaut's adrenaline starts pumping, I would imagine.
That's when mine starts pumping, just watching it.
You're right. 6 minutes.
T-minus 6 minutes. Orbiter test conductor giving pilot Gibson a go to perform the APU pre-start. Gibson will configure switches in the cockpit to put the APUs in the ready-to-start configuration. T-minus 5 minutes, 45 seconds, and counting.
Go ahead. Flight recorders on.
T-minus 5 minutes, 30 seconds. Mission Control now transmitting the signal to start the flight recorders. These two recorders will collect measurements of shuttle system performance during flight, also for playback after the mission. Flight reports that the recorders are running. T-minus 5 minutes, 14 seconds, and counting. Coming up on our next major milestone, a go for starting the 3 auxiliary power units. T-minus 5 minutes and counting. We have a go for APU start. Locks replenish will now be terminated and lock strain back initiated. Pilot Gibson now flipping the remaining switches in the cockpit, which starts the 3 auxiliary power units.
Okay, the APUs are...
They're the auxiliary power units. They provide hydraulic pressure that controls the positioning of the engines for ascent, and on entry control the positioning of the aero surfaces.
Safe and arm devices have been armed, and inhibit remains on the SNAs until T-minus 10 seconds when the range safety destruct system is activated.
And
main fuel valve heaters on the 3 shuttle main engines have been turned on now in preparation.
Looks a little cloudy to me.
Oh, there's some spotty stuff there.
T-minus 4
Looks
minutes.
like blue
and
sky above
counting.
it, though.
The crew has been asked to close the visors on their launch and entry helmets. Final purge sequence of the main engines now underway. T-minus 3 minutes, 55 seconds. Orbiter aero surface test underway. Flight surfaces being moved through a pre-programmed pattern to verify they're ready for launch. T-minus 3 minutes, 35 seconds, and counting.
Minus 3 minutes, 30 seconds.
Orbiter ground support equipment power bus has been turned off. The vehicle is now on internal power, running off its onboard fuel cells, being fed by ground reactants through the T0 umbilicals. Aero surface checks complete. Reported to be in launch configuration, now underway with the gimbal checks of the orbiter main engines. T-minus 3 minutes, 4 seconds and counting. Shuttle main engines now in the start position. T-minus 2 minutes, 55 seconds. External tank liquid oxygen pressurization has started, and purging of the shuttle main engine is terminated. Retraction has started of the gaseous oxygen vent hood. Ground launch sequencer will make a final check to make sure the vent is fully retracted at the T-minus 37-second mark. T-minus 2 minutes, 30 seconds and counting. Orbiter test conductor requesting pilot Gibson to clear the caution and warning memory system. T-minus 2 minutes, 20 seconds and counting. Fuel cell ground supplies have been terminated. Challenger now completely on internal power, running off its onboard reactants. T-minus counting, coming up on liquid hydrogen replenish termination. Go for ET pre-press on the liquid hydrogen tank. Vehicle now isolated from ground loading equipment. Beanie cap now being swung out of the way in preparation for launch of 41B on time at 8 a.m. Eastern Standard Time. T-minus 1 minute, 30 seconds away from the liftoff of 41B and its 5-man crew. At the T-minus 1 minute mark, the ground launch sequencer will verify the shuttle main engines are ready to start. T-minus 1 minute, 15 seconds and counting. Liquid hydrogen tank now at flight pressure. T-minus 1 minute and counting. Sound suppression system now armed. Hydrogen burn igniters also armed at this time. T-minus 50 seconds and counting. Solid rocket booster development flight instrumentation recorders going to record mode. T-minus 42 seconds and counting. T-minus 38 seconds. Orbiter computers positioning vent doors to launch configuration. Coming up on a go to take over control by the onboard computers. And we have a go for auto sequence start. T-minus 23 seconds and counting. Orbiter computers now in command of the countdown. T-minus 15, 14, 13, 12, 11, 10. We have a go for main engine start. 6, 5. We have main engine start. 3, 2, 1, 0. We have solid rocket booster ignition and liftoff of Challenger and the 10th Space Shuttle flight. And the shuttle has cleared the tower.
Tower, pitch program.
Houston now controlling. Roll maneuver confirmed.
15 seconds.
Good roll confirmed by mission control.
20 seconds.
25 seconds preparing to throttle down to 75% on the main engine.
30 seconds. 1.
Velocity 700 feet per second. Throttling down 73% confirmed as the vehicle prepares to pass through the maximum aerodynamic pressure. 52 seconds, velocity 1100 feet per second. Downrange distance 2 nautical miles, altitude 4.7. Throttle the engines back up to 100%. 3 engines down to 100%. Challenger Houston, your go at throttle up.
Roger, Houston.
Challenger and crew giving a go at throttle up. 1 minute 23 seconds, velocity 2,300 feet per second. Altitude 11 nautical miles, downrange range distance 9 nautical miles. One minute 45 seconds, velocity 3,400 feet per second. Altitude 17 nautical miles, downrange distance 17 nautical miles. Standing by for solid rocket booster separation.
PC less than 50.
Roger, PC. Solid rocket booster separation confirmed. Guidance converging is programmed.
Challenger Houston, first stage performance nominal.
Roger, Houston.
Nominal first stage of ascent during the SRB performance. 2 minutes 35 seconds, velocity 4,700 feet per second, downrange distance 48 nautical miles, altitude 33 nautical miles. Minutes, velocity 5,200 feet per second, downrange distance 70 nautical miles, altitude 39 nautical miles.
Another beauty, the USA gets its space bus off on time. They're ready when we are. And we're going to take another look at it. Are we all set to go? Okay, let's take another look at the launch of Flight 41 Bravo.
We have a go for main engine start. 6, 5. We have main engine start. 3, 2, 1, 0. Have solid rocket booster ignition and liftoff of Challenger and the 10th Space Shuttle flight. And the shuttle has cleared the tower.
Tower, switch program.
Houston now controlling. Roll maneuver confirmed.
15 seconds.
Good roll.
Everything is perfect.
20 seconds.
25 seconds preparing to throttle down. 275%.
This seemed to go a whole lot more smoothly than any of the others. I mean, the confidence level was high during the mission. Of course, a lot has been learned in the previous 9 flights. And they take care of the problems as they come.
And NASA makes it look easy. I promise you it's not easy. There are literally tens of thousands of things that have to go right every time we launch these things. And for those of us
4 minutes
directly involved with it, I don't think it'll ever be routine.
Per second, downrange distance 179 nautical miles.
Challenger Houston, press to MECO.
Challenger, roger.
Challenger given the call to press to main engine cutoff.
Main engine cutoff is the next order of business. We're 5 minutes into the flight. We'll have some ohms burns later on this afternoon. The first order of the day will be the deployment of the Westar 6, the Western Union satellite, which NASA is being paid $18 million to launch. That is the primary objective of this mission, to launch the Westar, and the Palapa B, the Indonesian communication satellite, which will be launched tomorrow. That's the primary goal. The most significant goal in this mission, according to all of the men on board whom we have talked to prior to the mission, will be the MMU spacewalk and the practice for the rescue, or rather the capture and the repair of the Solar Max satellite, which has been floating around there, spinning around and been ineffective for several months. The Solar Max satellite is to study the solar flares and the solar physics of the sun, and at a cost of about $100 million, this is going to put some life into that.
Yes, sir. And more importantly, from our point of view, it demonstrates our capability to do similar kinds of operations with other satellites that have exceeded their operational life. And if we can go up and refurbish them, we'll save a lot of money that would otherwise have to be spent on new systems.
And it will also be practice for future construction of that space station, which we've heard so much about, which we'll be talking about as the 8 days of this mission continue. One thing we neglected to mention, but which is another first for this mission, is the landing a week from Saturday morning, just shortly after sunrise, at the Kennedy Space Center on the concrete runway there. That was attempted once before, but that mission had to be waved off because of bad weather. All of the flights have landed in the desert, one at White Sands, New Mexico, which you may recall, the rest in the Mojave Desert out in California. We're going to take a short break, and we'll be right back.
13, 12.
They'll be opening the payload bay doors here in another 30 minutes. Prior to that time, we reconfigure the computers. We put one of them to sleep in a standby mode in case we needed it to come home quickly. Two of the others we load in with software that supports the on-orbit operation. Okay. And that's what they're doing right now.
Some conflicting schedules here on the Cable News Network. Today, Mike mentioned the opening of the payload bay doors. We'll have live TV